I'm going to be talking about Sprint 24. Sprint 24 reads, a square is inscribed inside a quarter circle with radius 1 as shown below. The circumcircle of the square is drawn. There are two non-overlapping regions here and here, inside the quarter circle and outside the circumcircle of the square. The area of one of these regions can be expressed as the fraction pi plus a over b for non-zero integers a and b. What is a plus b? So first of all, we know that the radius of this larger circle is 1. So the diagonal of the square must also be 1 because this point of the square is at the center of this large circle, and this point of the square is on the circle itself. So since the diagonal of the square is 1, then the diameter of the circumcircle must also be 1. So the radius of the smaller circle is going to be half of that, or 1/2. So since we know the radius, here we have it drawn out. Specifically, I drew the radius of this, or the diameter of this circle as the diagonal of the square, and I also drew the altitude of this little triangle that we formed, which is also the radius of the circumcircle. So as I said, this diameter is length 1, and this right here is length 1/2. 1/2. So since we know the radius of this smaller circle, which is 1/2, we can find the area of the circle. That's pi r squared. So the radius is 1/2. 1/2 squared is 1/4. Pi times 1/4 is pi over 4. So now we know the area of this entire circle here. Since we know that, we can, instead of finding the area specifically of one of these sections of the circle, it's probably going to be easier to take the area of the entire circle and subtract from that the area of the overlapping region, which is right here. That's made up of half of the circle, which is this part here, plus this triangle, which fortunately we already know the base and height of, so we can find that pretty easily. First, half of the area of the circle is going to be half of what we just found, pi over 4. So that's going to be pi over 8. And then this triangle here, well, we know that the base is length 1, and the height is length 1/2. And the area of a triangle is base times height divided by 2. So it's going to be 1 times 1/2 divided by 2. So what we get for the area of the entire overlapping region is pi over 8 plus this, which is the area of the triangle, so plus 1 over 4. And that's the area of the entire overlapping region. So since we know the area of the circle, as well as the area of the overlapping region with the larger circle, we can subtract the area of the overlap from the total area of the circumcircle to get the area of both of these regions right here and right here. And when we subtract, we get pi over 4 minus pi over 8 plus 1/4, which simplifies to pi over 8 minus 1/4. That's the area of both non-overlapping regions. So we want the area of only one of them. So we're going to divide this by 2. And when we simplify that, we are going to get pi over 16 minus 1 over 8. Now remember, we want to express the area of one of these regions as pi plus a over b. So we want this to be simplified into a single fraction, which means we need to find a common denominator. And since we know that 1/8 can be expressed as 2 over 16, we can simplify what we have here as pi minus 2 over 16. Now that means -2 is a, and b is 16. So since we know that, we can add them. A plus b is going to be 16 minus 2, and 16 minus 2 is 14, which is our answer. And we're done. Thank you.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.